So today we're going to work on section 6.5, which is operations with the radical expressions. And we're going to be working on things other than just square roots. So to multiply, you can only multiply if you have the same index. So that means square roots, third roots, fourth roots. We can't multiply a square root by a third root as is here. So again, multiply the coefficients. So we'll get 8. And then we'll have the square root of, I have 6 and 6, so I'll just write that as 6 to the second. And then I'll have x to the fourth. And then I have y to the fifth, but I'll write that as y to the fourth and then one more y. And we're doing operations, so we don't need to worry about absolute value here. So the square root of 6 squared is 6, so I'll have 8 times 6, which is 48. And then the square root of x to the fourth is x squared. Square root of y to the fourth is y squared. And then I have the square root of y. This next one we have cube roots. So I'm going to have 4. And then the cube root. And I have 2 and 10, which will be 20. And I'm just writing that as 20 because there is no perfect cube that is a factor of 20. And then x squared and x to the 6, I'm going to keep that as x squared and x to the 6 because x to the 6 is a perfect cube, but x squared is not. So I'm going to just go ahead and take the cube root of x to the 6, which was x to the second power. And then what's left is my third root of 20x squared. And just be careful when you're putting your index, and my3 is a little messy there, but make sure that your index is not looking like an exponent for any variables you might have out in front. All right, the next one, we have a square root and a third root. So this one cannot be done. There's different index. Okay. So why don't you pause the video and try the next few before I explain how to do them. This would be the square root of 15 times 6. So I'm going to write that as 5 times 3. And then a 3 and a 2 for the 6. Oops, there we go. So that's a perfect square. So I'll get 3 and then square root of 10. Right, the next one, we have cube roots. So I'll write that as 3 times 2, which is 6. And then we have a 25 and a 5. If I multiply that together, I'd get 5 to the third power, or 125. So that's a cube root. So I have 6 times 5, otherwise known as 30. The next one, we have square roots again, so we'll do the square root. And then we just have 15xy. Nothing can be simplified here. For 4, we'll get 8. And then the square root of 18. 18 I can break down to a 9 times 2. 9's a perfect square, so out comes a 3. So I have 8 times 3, which is 24, and then root 2. For number 5, and this is important for later on in the notes, this is our difference of squares, our a minus b times a plus b. So I get 5 squared minus root 3 squared. Remember, our square root and our square undo each other, so I really get 25 minus 3, which is 22. And then the last one, we have a cube root, so I'm going to do the third root of 24. And 24 I know is 8 times 3, and I'm breaking it down because 8 is a perfect cube. Then I have x to the fifth, x to the third, that's going to be x to the 8th. So instead of doing x to the 8th, I'm going to do x to the 6th and x squared. And then I get y to the 3rd. So I want to make sure I write my exponents so that they're multiples of 3. So perfect cube, perfect cube, perfect cube. So we get 2 x squared, y. And then the third root, what's left in the radicand, is 3x squared. I'm just going to make that symbol a little bit longer so you can see everything's inside that radical there. So now we're going to divide radicals, and sometimes we'll have to rationalize the denominators. That means, remember, you can never have a radical in your denominator when you're finished with your answer. I like to look and see if I can first simplify any fractions that might be in the radical. So we have the third root of 40x to the fourth. Oops, I lost that there. Over 5x. So what I'm going to do is I'm going to actually divide. 40 divided by 5 is 8. And then x to the fourth divided by x is x to the third. And what do you know? They're both perfect cubes. So I get 2x. Number 2, we have root 5 in the denominator, so we have to multiply by root 5. Because then we'll have 5 squared as our radicand. So what is root 5 times root 5? Just 5. And then the numerator is 4 root 5. For number 3, it's not one fraction, but notice they have the same index, so I can go ahead and simplify this component right here. So I have root 12 over root 2x. So 12 divided by 2 is 6. And then root x stays in that denominator. So I need to get rid of the radical in the denominator, so multiply by the square root of x over the square root of x. And that will give me the square root of 6x, which cannot be simplified, over 3x. All right, this next one, we have the third root of 7 over 9. So I can't simplify 7 over 9, so I'm going to, oops, lose that page there. I'm going to rewrite it as the third root of 7. And then there's a little trick I want you to start using. Instead of the third root of 9, let's write the third root of 3 to the second power. Always, if you have something that is a square or cube, write it so it's a base to an exponent. Okay. Now, the reason why I want to do this is if you notice, we have a third root. So in order to get rid of our radical here, we have to multiply by something that will make our radicand a perfect square. We only have to multiply by the third root of 3 to the first. You could multiply by something larger, but why do that? Because that's just going to make more work for yourself in the end. You'd have to simplify more. So I'm going to multiply by the third root of 3 to the first, because what that does is that will now give us, in the denominator, the third root of 3 to the third, which is a perfect cube. And the numerator, I have the third root of 7 times 3, which is 21. So now I can go ahead and write my final answer. It's the third root of 21 over 3. Let's try another one similar to that. Number 5, we have the third root of x to the 6 over y to the 7. So if you look at that, we do have a perfect cube in the numerator, so we can go ahead and take care of that. The third root of x to the 6 is x squared. And I'm going to leave this as the third root of y to the 7th here. There's a couple different ways you could approach this. But what I want to point out is I want to get the exponent for the denominator to be a multiple of 3 because that's my index. So I'm going to multiply by the third root of y to the 2nd because 7 plus 2 is 9. All right, so I'm going to show all the steps. When you get good at this, you're not going to have to do all of that. So I have x squared and then the third root of y squared. And in the denominator, I have the third root of y to the 9th. And the third root of y to the 9th leaves us with y to the 3rd power. And then the numerator, I have x squared. Can't simplify that y squared, so it's going to be the third root of y to the 2nd. Sorry, my writing's a little messy there. So number 6 is the fourth root of 2 over 5x to the 2nd power. We can't simplify the fraction, so I'm just going to go ahead and look at what I have in my denominator. So this is 5 to the 1st power, and then x squared. So what I really want to think about is I want to get these to all be 4th powers. So I'm going to multiply by 5. Since I have 1 here, I'm going to do 5 to the 3rd. And then this is x squared. To make it a 4, I need an x to the 2nd because 2 plus 2 is 4. So to rationalize this, we're going to multiply by the 4th root of 5 to the 3rd x squared. So my denominator will become, and I'm just going to do the denominator here, put n for numerator, the fourth root of 5 to the fourth, x to the fourth. They're both, again, fourth roots, so the denominator will be 5x. And in the numerator, we're going to multiply that root 2, or actually fourth root 2, times the fourth root of 5 to the third x squared. So 5 to the third would be that 125, and then times 2 gives us 250. And again, because it's a 5 to the third and 2, there are no fourth roots. So I know I can't simplify that because we had our primes. And then we just have x squared. So that one is simplified.